Hi, so here I'm gonna explain in a very simple manner uh, one of the two examples I have developed and made for providing a range of uncertainty on well-testing analysis results. So basically, when you carry the analysis of your log-log plot and derivative and that you produce a value for the skin, the wellbore storage, the permeability, the conductivity, and different type of distances. It could be a distance to a fault, it could be a radius of investigation. Well, you get a fixed value. Eventually, you get some uncertainty linked to the regression. Here we're not showing how to include the regression uncertainty. Uh, we but we try to show you with this, if we assume that the given value you get is your most likely value, uh, we get or your mean, we get an uncertainty around it. So this is the way it works. I have two versions, one that is pretty complex using Monte Carlo analysis. This one is simpler and use the result of my SPE thesis. It's it gives an uncertainty range that has already been calculated, but we have to specify or I have to specify the condition. This is for oil case, so oil well. You have to add also it's for vertical well and for a reservoir with homogeneous behavior as opposed to double permeability or double porosity reservoir. So basically here you input a value. So let's say for example 5 for the skin, and if you want to look at it for the skin, of course, and you can click and you get a minimum value and a maximum value, which are the two extremes. The minus range and this is not a range, this is the final result of the skin when the range is applied. And now if you want to try a new value, you can with another result, you can, for example, you can switch here and go to another uh, output, but you have to note this is the same value standing, so you can change, you have to change the value afterwards. So imagine we're looking at permeability and checking 300 millidarcy millidarcy reservoir. We have to click again on the option and we get a low value of 240 millidarcy and 360 millidarcy. Same thing for the KH. The units will be specified, uh, and you see the value changing for RI. So if you have, for example, 300 meter to a fault, you get the lower value, and the high value you get the P90. I mean it's you get the P90 and the P10. If you check wellbore storage, so wellbore storage, it's usually something looking more like that, if depending on the units that you're using, and you're getting a low and a high value. Um, Here we have defaulted to 2 decimals. Most of the results in the final version you get more decimals on the wellbore storage. So if we get 0.1, for instance, we have to click again since we have changed the value of the input on C and we get a low and a high case. This has been rounded because it's probably out, it's not captured with two decimals. And here it is. So it's a very simple tool to get a very potent result based on a SPE thesis that I will provide. And if you're looking for the more advanced version, if you need probability distribution on your permeability or your wellbore storage or your skin or even distance to a fault, if you want also to look at the behavior of this probability density, if you see that it has one peak or two, or that the probability is evenly split, or is going more toward one given direction. These are things you can have. This simple version is made free for many months, starting from September 2018, for trial and testing. It will probably shift for an abonnement price, and there will be the more complex version that will be made available soon. Thank you.